So I got a question about problem 3, I think. Yeah, problem 3 on the homework. So my version of problem 3 is estimate the area under the curve of the function 4 over x from the x value 1 to 5 with 4 approximating triangles. Really close to the problem that we did at the beginning of class Thursday and at the end of class Tuesday. So let's see what graph looks right. So they want 4 approximating triangles at the right endpoints. So here's 4 approximating triangles from 1 to 5. That looks good. And all of these endpoints touch the graph on the right side of the rectangle. So here it touches it at the left side of the rectangle. We don't want that. Left side of the rectangle, no good. The middle of the rectangle, no good. We want it touching on the right endpoints. So that's this graph. Okay, and then it says, is your estimate an underestimate or overestimate? So look at these rectangles. See how the area under that curve is going to be an underestimate because we have some area under the curve that hasn't been approximated. So there is that area that I'm pointing to that hasn't been accounted for. So the area of those rectangles is going to be underestimate because it doesn't account for some of that area under the actual curve. Okay, and how do we actually estimate that area is we're going to understand that the width of each one of these is 1, so it's going to be 1 times what? Well, let's see how tall it is. It goes up on the right side of the rectangle, and so what's the y value that corresponds to 2? So I plug in 2 into the function. 4 divided by 2 is 2. So the first rectangle is 1 times 2, which is 2. And then the next rectangle is 1, there's the width, times what? 4 over 3. The input is 3, plus 4 over 3, plus the third rectangle, 1 times 4 over, look, it goes up and hits it at the y value that corresponds to 4. 4 over 4 is 1. And the last rectangle has a width of 1, so 1 times, what's the y value when you plug in a 5? 4 over 5. Okay, and now I just have to calculate that up. Maybe I'll use Desmos to do that. Control C, and then Desmos. Control V. All right, that ends up being 77 over 15. Let's see if that's what they want. 77 over 15. Okay, that looks good. And then we do the same thing with left endpoint. So see how the rectangles here hit it at the left endpoint, so that's good. This also hits at the left endpoint, but let's make sure, what's the difference? But oh goodness, it didn't hit at the left endpoints every time. Hit the left endpoint, and then you got a right endpoint. It's all over the place. That's not good. Left endpoint, left endpoint, left endpoint, left endpoint. Okay, perfect. So it's this graph. And you can see that's an overestimate. It's calculating area that it's not under the curve, so that's an overestimate. And so what is the actual area? So look at the area of the first rectangle. The width is 1, and the height is 4 over, or sorry, plug in a 1, 4 over 1, which is 4. What am I doing is I'm plugging in the x value that corresponds to the y value that touches the graph. So in this case, plugging in x value 2 into the function. Here's the function up here, 4 over x. So if you plug in a 2, 4 over 2 is 2. Now what do? We plug in, what, a 3. So 4 over 3. 4 over 1, 4 over 2, 4 over 3. And now the last one, what? 4 over 4, which is 1. Okay, let's see what that is. Copy those calculations into Desmos. 25 thirds. Make sure that that's correct. Okay. 25 thirds. Looks okay. Remember, this is an underestimation. I just accidentally hit that one. Okay, so hopefully that helps with that last problem on the homework, and talk to you next week.